Differential coefficient at a point. Now the same derivative can be at a point can be written in this fashion. Like f of x be a real valued function defined for an open interval AB, defined on an open interval AB, and C belongs to AB. Then f is said to be differentiable or derivable at C if the limit f of x minus f of C by x minus C exists and is finite. So this is just another way of writing it. So I'll just show this. Another way of, instead of taking a plus h and a minus h, this is another way of representation. Now let's say this is a curve again, and this is the point C, and this point A has the coordinates C comma f of C, and we choose any arbitrary point B and we write in terms of the general variable. So B will be x comma f of x. So what is slope of AB? Slope of AB is f of x minus f of C by x minus C. Now when we, so this is the chord AB, and we can extend this chord. So it becomes a secant. Now when we take the limit of this, limit as x approaches C. Now x can approach C either from the left or from the right. So it doesn't matter. So both are taken. So f of x minus f of C by x minus C. So if this limit exists, that means left hand limit is equal to the right hand limit, which means the tangent from the tangent at A from the right and the tangent from A from the left will both coincide. There will be a same straight line. Then f dash C, which is the value of the limit, is the differential coefficient or the derivative of the function at C. That's what it means. Okay. So this limit is called the derivative or differential coefficient, and it has this notations. So the same thing, instead of a plus h, a minus h, we have written this way. Now, so this is another way of writing. Now what to do next? This is differentiability on an interval. Differentiability on an interval. A function f of x is differentiable on AB if function is differentiable at each point in the interval and also at the endpoints. So a function is said to be differentiable on closed interval AB if at every intermediate point on the interval it is differentiable and also at the endpoints. Now at the endpoints, how do we define? So at A, only the right hand derivative must exist. That means it should not be infinity, or you cannot, a function is undefined at that point. And then left hand limit at B, it should exist. Then we say function is a differentiable function. Function is a differentiable function. If it is differentiable at every point on the interval, then it is said to be a differentiable function, and a function is said to be a differentiable function if it is differentiable at every point of its domain. So this about differentiability. Now the important point, derivative of function at any point. This is what we deal with most of the time. Derivative of the function f of x at any point x. So far we said at A, at C, that's how we are discussing. Now at each and every point in the interval, now I want derivative of the function at any point. So we choose this fundamental derivative. Go to the very first section that we discussed today. F of a plus h minus f of a by h, f of a minus h minus f of a by minus h as limit h tends to 0. So if a function is differentiable in its domain, then its derivative at any point is given by this fundamental value. F of limit h tends to 0, f of x minus h minus f of x by minus h, or limit f of x plus h minus f of x by h as x tends to 0, as h tends to 0. So the right hand derivative or the left hand derivative, both will be equal because it's a differentiable function. So this, when we don't write a here, in the previous case it was a minus h, we have replaced this a with a general variable x. We have replaced a with the general variable x, then and we made h tend to 0, so we get f dash x, and this is how we get the value of all the derivatives of all the functions from this fundamental derivation, or we call it differentiation from first principles. All these formulas we obtain. What is that? Derivative of a constant is 0. So derivative of a constant is 0. Derivative of x power n is n x to the power n minus 1. Derivative of e power x is e power x. Derivative of a power x is a power x log a. Derivative of log x is 1 by x, and log mod x is also 1 by x. Derivative of log mod x to the base a is 1 by x by log a to the base e. Derivative of sin x is cos x. Derivative of cos x is minus sin x. Derivative of tan x is secant square x. Derivative of cot x is cosecant square x. This is a mistake here. This is cosecant square x. Cosecant square x. Derivative of secant x is secant x tan x. Derivative of cosecant x is minus cosecant x cot x. Derivative of sin inverse x is 1 by under root of 1 minus x square. Derivative of cos inverse x is minus 1 by under root of 1 minus x square. Derivative of tan inverse x is 1 upon 1 plus x square. Cot inverse x is minus 1 by 1 plus x square. Derivative of secant inverse x is 1 by mod x under root of x square minus 1. Derivative of cosecant inverse x is minus 1 by mod x into x square minus root x square minus 1. Now these all formulas have been derived from this expression, and these are standard. For example, we have done this. We have done this, right? Limit x tends to a f of x, x power n minus a power n by x minus a is what? N a to the power n minus 1. This is what? This is a derivative of which function? F of x is equal to x power n, where at x equal to a, as x tends to a. Okay, so that's the derivative of this function. So like that, so that's why derivative of x power n is n into x power n minus 1. So before I go into derivatives, now let us so this is the basic formula, and for a gate it is assumed that you know derivatives and you know how to differentiate. It is just assumed. There are no questions given directly on derivatives. They are given on application of derivatives. There are questions on continuity and differentiability, but not on derivatives. Application